still a lot of room to do more in this space, and that's why I'm very excited to introduce some of our guests that we have here today for this discussion. We have Misha, who is a product manager at KEVLAR. We have Nico, senior business manager at Polymaker, and we have Nate, who's an application engineer at BASF. Welcome to this session. I think we're going to have a great discussion today, and I want to start with a quick introduction. So maybe Misha, you can start giving a quick introduction of who you are and what your company does.
Hello, everyone. Very excited to be part of the discussion today. So I'm Misha. I'm part of KEVLAR, so I'm the product manager at KEVLAR. So my role in KEVLAR is really to be the link between R&D and sales and marketing in all that is linked to the materials at KEVLAR. So that's my role. I am historically, I am an engineer, so I started off as an R&D engineer, and then throughout my career, I have actually used 3D printing in companies I've worked for, well, mainly for prototyping. So I worked in an electronics drone company in the beginning, and then in my previous experience, it was in a startup where 3D printing was essential for us before actually mass production using regular production, like through injection. So it's really exciting for me to work for KEVLAR, as I see that now, we will talk about it, but how 3D printing has really taken over, and it's not just for prototyping, but also for mass production. So KEVLAR is part of Armor. So just briefly, I'll talk more about it later, but Armor, the group itself is nearly a century-old group that started off really in carbon paper, so printing as well, but carbon paper. And then in ink, printing ink formulation. And then now we have different business units and in new tech, and we have solar panels and another business unit that is KEVLAR, of course, in 3D printing. So it's very exciting to be part of the discussion. Thank you.
That's great. Thank you.
Yeah, I can go next. So hi everyone, my name is Nathan Woods. I'm an application engineer here at BASF 3D Printing Solutions. So I work out of the Metro Detroit area in the US. So primarily my role has really been to provide technical support to end users of our materials, application development, and some more back-end technical development projects as well. So I have a fairly broad span of responsibilities here. So for the past year and a half, been working on supporting filament materials. So this includes both of our polymer-based and metal-based portfolio. Prior to that, I spent a little over 2.5 years doing research and development for our photopolymer materials. So a second and separate business line that BASF focuses on. So grand total, about a little over 4 years at BASF, all in that Metro Detroit area, where we're continuing to really build up our capabilities. I'm sure we'll get to this a little bit later, but yes, so yeah, we have, well, the primary focus for today is obviously on filament materials, but right, our group does focus on photopolymer liquid resins as well as powder-based materials as well. So yeah, looking forward to talking today. Thanks.
Yeah, sounds great.
Thank you. So I'm Nicholas from Polymaker. I'm a business manager at Polymaker. Nice to meet you all, and very exciting for joining this summit with KEVLAR, MakerBot, and BASF. So before being a business manager at Polymaker, I've been in Polymaker for 5 years. I started as a 3D printing engineer, learning a lot about materials. I actually wrote a material science chapter in 3D printing troubleshooting books that is selling very well on Amazon. If you have issues with your 3D printer and you want to understand it in a more material science side, I design. I own a collection of toys that I design, 3D printable toys. So I have my own printers. I print a lot. As a college student, I co-founded a startup focusing on developing 3D printed wearable devices. And So I'm really excited to share more today about materials and how the collaboration between material and printer manufacturers is really the key to develop the 3D printing industry.
Thank you. Yeah, I think you bring up a good point and something that kind of bridges perfectly into what I was going to talk about. I think you know, it's really the 3D printing space is when you think about 3D printing, it's a very complex process, right? Because we're talking about heat inside a machine that has electronics, and you're melting material. And so because of the complexity, I think that in our industry, it's paramount for us to collaborate and focus on one thing. And like you said, for us, MakerBot as a machine manufacturer, it's crucial to partner with experts like you guys who are focusing on the material side of things, because one company can't do everything on their own. And we really realize that. And that's one of the reasons why I wanted to also give a little bit of context on specifically when it comes to MakerBot, what we're talking about here and why it's this group of people. So the method, as I mentioned, I'm not going to go into all the details. Everyone on this call can do their own research on the platform, but essentially this platform is very different from any of the other desktop 3D printing platforms in that price band, because it uses some of the industrial features from Stratasys, and mainly to point out here is the heated chamber that we use, which makes it easier to print industrial 3D printing materials because you control the printing environment. You have better dimensional accuracy as a result and better layer bonding. So with that, you know, that in combination with the fact that we opened up the printer, so now you can print all kinds of third-party materials on the platform, makes it very powerful. And we didn't just want to open it up and say, go out and print whatever you want. We wanted to partner with companies like KEVLAR, like Polymaker, and BASF to really develop profiles for the materials and verify that they print well, and then publish the print settings. So we have a materials development program, and all the speakers on this panel today are part of that. And they basically go or research on their own materials and then print them on the MakerBot, go through a certification sequence, and then share the settings and results with us. And that's what we publish out to our users. And it's ever growing. When we first launched the method, we had 3 materials, and just over the last year, we went up to 25 different materials. So really a growing range of materials, and I think there's a lot more to come. And each of you has a little bit of a different focus in terms of a company. So I do want to talk, there are a couple of different things we're going to talk about today. I do want to get into the applications and specific examples for materials that work on our platform that we can talk about. We can talk about, you know, the future of like where things are going. But I do want to start with maybe each of you talking a little bit more about the focus of your company when it comes to materials, right? Like each of you have a little bit of a different focus on the types of materials that you focus on. So maybe Misha, you want to start talking a little bit about the types of materials?
Yeah, well, yeah, if I could just talk about the KEVLAR, so what we offer today. So just to give you an idea, so at KEVLAR we have 3 different services, 3 groups. We call it KEVLAR Materials, which is really the part of our business where we focus on producing materials and the materials that are part of the MakerBot open program, for example. Then we have KEVLAR Lab, where we actually formulate specific materials for specific customers. So it's mainly industrials who come to us and ask us, because they have a specific use case where they need a material that does this, and something that we don't have in our catalog. So that is another service we offer, KEVLAR Lab. And then we have KEVLAR Factory, so where we have what we call in France like a farm, so a printing farm. So we have a lot of range of different types of printers, so different brands, and in our site here that allows us to print for companies as well. So you really have to see KEVLAR as 3 different business services. So the KEVLAR Materials, KEVLAR Lab, and KEVLAR Factory. So I think that's what makes us different as well. from all the other, there are lots of people out in the market today, but really what makes us different is really our KEVLAR lab and KEVLAR factory, because we have chemists in-house as well to produce specific materials. And we have the capacity to print parts for industrials and for our customers. And if we just talk about our KEVLAR materials, to answer your question, so we have a full range. So we divided it into three. Again, we have standard materials, which is PLA, ABS, PTG materials in different colors. Then we have our technical materials, or some call engineering family of materials, where we have flexibles. We have the composites like the ABS carbon, ABS-EC, ABS-ESD. So some materials that we will talk about later in our case studies. And we also have the chance to have high performance materials, which is not common, but we're quite proud to be able to produce high performance materials as well. So this goes from, what PE 9085, PE 1010, but also PEC. So, we're one of the few that offer PEC materials. So we have a PEC A, a PEC carbon, and a PEC SC as well. So we really have the full range in our KEVLAR materials service, because we know that, today our customers are not only looking for PLA and ABS, but also looking for more technical, more specific needs in 3D printing.
And one thing that I noticed about the material offering that you have is that you have quite a wide range of different composite materials, which is a big trend right now. It's not just a carbon fiber, you have like a KEVLAR, ABS KEVLAR, you have a active material. So I think is that like a core focus that you guys have, and why do you think composite materials are so popular too?
Yeah, we definitely see that. Well, KEVLAR, if we look at how we are placed in the market today, we definitely stand out thanks to our technical and our high performance materials. And one of the most asked for materials, really our technical high performance, are our ABS carbon, ABS KEVLAR, because of the KEVLAR name, of course, it's very popular. And a trend we're seeing, and I'll talk more about it later, is ABS-ESD. So electrostatic discharge ABS material that is doing really well. And we see more and more industrials having a need for this material, because of, the way tooling is and the way factories are today. You need a lot of ESD safe materials, and this is one material that is part of the MakerBot Open Materials program that is really very popular. And we have lots of customers who are asking us for this material. Unfortunately, I can't. You'll see later on. I won't be able to show you pictures because it's a lot of confidential case studies, but it's a very interesting material that does well today.
That's great, and that kind of brings us also to Nate. Obviously BASF is very well known for the ultrafuse material, the stainless steel 316 now, so which also is a composite material. So maybe you can talk next about. So our portfolio is relatively similarly broken down. So we have like your standard range, we call it engineering range, which is like your polyamide, polypropylene, like carbon or glass fiber reinforced, and then higher performance, very high demanding applications with our materials like PPSU as well. So we have a lot of focus on this polymer based portfolio, but I think you're right. What really differentiates us is the metal filament. So currently we have two stainless steel materials, so 316, which is your general all-rounder, easy to machine metal material, but also the 17.4, which is a much higher strength, much stiffer metal material, which is more widely used in like these higher demanding industrial kind of applications. So, both of these shining features of this metal material, you can print it on MakerBot printers very well. You can print it on many desktop printers in general. So I think that's the kind of what we're really trying to focus and enable end users to actually just print and produce their own metal parts very cost effectively and very open, kind of an available manner. So so that's really, I think, where BASF shines on the filament front.
right, I mean, we have other like photopolymer materials and powders, which I don't really focus on, and right, I won't say too much more about it just because it's a little separate. But yeah, I mean, I would say we as a group are really trying to enable more industrial and advanced applications. So right, trying to continue the momentum of end users from learning what 3D printing is and like these rather basic prototypes to the more advanced prototypes and low series parts, replacement parts, and so on. So I think that's really where we're trying to help enable the general industry towards.
Great, and I think Nico, obviously Polymaker is very well known in the industry, and you guys also have a similar mission to make industrial materials more accessible, especially with your polycarbonate materials and many other innovative materials that you have. So maybe you can give a quick overview of your guys' focus.
Yes, definitely. So for Polymaker, to understand a little bit more, the focus that we have at the moment is to understand what's our goal, the mission. Polymaker is really committed to lowering the barrier to innovation and manufacturing, which 3D printing is really playing a role in this. And all of this by developing the 3D printing materials technology for industries and consumers. So with that in mind, the focus we have is really on the material research and development for extrusion-based 3D printing. So what makes our company different is more on the thinking process to develop a material that involves three main parts. The first one is printability, second is functionality and applicability. So printability is more on understanding the process where the material is going to be used. So which means, you can have extrusion-based 3D printing as, a desktop printer that may not have features from an industrial printer. You may have printer like the Method X that has additional features such as the heated chamber, or you can have a complete pallet printer, this huge printer printing, furnitures, for example. So we have this first step of understanding where the material is going to be used for. The second one is the functionality. So functionality is more on, understanding what is the properties that the customer is going to need, whether it's, more the mechanical properties on, stiffness, impact resistance, chemical resistance, etc. And then understand the material physics and the material behavior in that specific process in order to make it printable. So once we successfully match this printability and functionality, the last part is applicability. So it's great to have, a great material that prints well, function well, but now you need to create that solution. We do not make printer, we do not make slicing software, we do not make, testing software in order to ensure, great printability at first try. So we also try to create that, solution that will combine the material, the hardware, and the software. So that's where we're more focused on. And then obviously out of this, development, we have products that came out. We obviously focus on our nylon. So with that in mind, our nylon are all reprocessed in order to be more printable while delivering the functionality. Our polycarbonate is the same, before having access to platforms such as the Method X, we had to develop polycarbonate that could be printed with processes that won't have, the luxury of having a heated chamber. But I will come back later to that. But thanks to, this new platform that actually help material manufacturers to expand portfolio. So nylon, PC, and then obviously I will talk about this later, but we have seen a huge gap now between consumer, prosumer, and industrial application, and that force manufacturers to create, different product in different way, different thinking. But to summarize, what we want to do is to help customers to innovate and lower the barrier on innovation. And what makes us different is more the thinking process behind developing material, printability, functionality, and applicability. So that kind of summarized the focus for Polymaker.
Yeah, no, that's great. I think what you mentioned is an interesting point, that sometimes you have to kind of balance printability and the properties of the material based on the platform. And by expanding the printer platform, you can basically expand the horizon of what you can do and what you can achieve. And I think your polycarbonate materials are a very good example where you have a pretty wide variety, and some of them, they need that extra temperature print well, and so you've seen good success with that on the method. Just to give one example, but that's another example of how the materials development and the machine development have to go hand in hand, because you guys are constrained by the machine, and if you kind of expand that, then you can go in other directions, right? And for us, it's kind of important to understand that, and obviously we are expanding our own platform by adding these new materials that you guys are developing. Yeah, I think probably the most interesting part about materials is talking about the actual materials and the applications and what you can do with it. This is something that fascinates me, every single time I talk to a customer, because most of our customers are engineers that, they don't have the budget necessarily to buy a $100,000 printer. So they see what they can do within their budget, and then they bring in the printer, and maybe they have a use case in mind. But then as they explore new materials, suddenly they think, oh, now I can print this end effector, or what about if I print this fixture? And that's kind of how they explore inside the organization what's possible with 3D printing, and how they get buy-in also from the organization. So that's where I think the materials are key, but just as much as the materials are the applications. And that is, I think, a key challenge in the overall industry, is to kind of explain the different applications that are possible, and also what material should be used for which application. That's a big challenge too, right? Because there's a pretty wide variety of different materials out there. So which material is right for this application? It's a really big question. So I think next, what would be very interesting is for each of you to pick one of the materials, one or two of the materials that work on the MakerBot method platform, and go a little bit more into detail about the material, the properties, and show some example applications. So let's follow the same flow. Maybe Misha, you want to start with yours, and I know you have some slides.
Yeah, so I will share my screen just to show you a few pictures. Let me know if you see the screen. Yes.
Yes.
Yeah.
Okay, great. So I just compiled a few case studies focusing on 3 materials, which are part of the MakerBot Methodix platform, open materials platform. So the first one is, well, the first 2 are based on the ABS carbon. So this is a composite material that a lot of people are familiar with, but just to summarize it, it's ABS with the chopped carbon fibers incorporated into our ABS. That makes it that improves its strength and cohesiveness. It's lightweight, and of course we decrease the usual delamination that you can find and warping, thanks also to the Methodix printer and printing it in a closed chamber. So this is an example of a case study that was up recently. So these are actually blade holders that are mixed with traditional, I'm just going to move it, sorry, traditional manufactured blade holders in one of our robotic slitting cells. So, here that when you see a 3D written on it, so we didn't replace all the blade holders, but some of the blade holders that were faulty, this company replaced it with 3D printed ABS carbon blade holders. So this is an example of, in industrial use to replace a part. And instead of printing it out through regular tooling, an engineer that was in the factory used the same design. There was very little change to the actual design itself for 3D printing to be able to print these pieces. So it was really to 3D print a functional piece and to save on manufacturing costs. And you can see a zoom here of the piece itself. So the carbon fiber, of course, here helps to maintain rigidity. And at the end of the day, they were able to replace pieces at a lower cost than what you would traditionally spend on a regular type of manufacturing for this sort of piece. So, this is a good example that was just done recently for this company where, it's also being agile, being able to react on the moment. You need to replace a piece. It could be just 10 pieces, but it's also a big cost to spend on tooling. So they replaced it easily through 3D printing.
And that's also, I think the other piece of that is cheaper than tooling, but also you don't have to hold inventory, because you
Yeah,
can
exactly.
demand, right? Which is something
Yeah.
that a lot of companies are looking into right now is why should we hold all of this inventory? Because we need, if you have a lot of replacement parts, it can be quite a big inventory that you have to hold, and you may never use them, or it takes a long time until you actually use them. So with 3D printing, I think that's one of the key benefits. You can print it as you need it. You can just have the digital file saved and know which materials to print them in, and then print them as you need them.
And it can be adapted. And yeah, it's really the essence of 3D printing is only printing what you need. So this is perfect for it. The second example was, it's also in a factory. So, you know, it's this was also ABS carbon. So a robot that picks up a cardboard here that you see that goes over a conveyor belt. So it's very similar in the type of application because, you know, it replaces a previous traditional piece. And here carbon fiber was interesting because of the durability, the strength of it, and also to have a higher flexural modulus to maintain the robotic position. So this is an interesting case study as well. And then, as you can see, the company managed to save costs by using 3D printing here. So this is an example of ABS-KEVLAR. So ABS-KEVLAR, which is very similar to ABS carbon. The example I have here is also more and more, I think that this is we have lots of examples of jigs and fixtures uses of 3D printing. So this is one example where we replaced 3 different bearings in a part that supports a rotating shaft. And so to do this, they have to press out 3 small pins in varying locations of the part. So they decided to use 3D printing to replace this part. So this is it's part of the jig. So why did they choose ABS-KEVLAR? Because also they needed a slightly higher impact resistance and a lower flexural modulus than ABS carbon. So that's why it was interesting for us to have, not just ABS carbon, but ABS-KEVLAR as well, because there are some very small differences between the properties in the material, but sometimes it could be more more interesting to use ABS-KEVLAR instead of ABS carbon. So this is one example of it.
And one thing I wanted to mention also is, obviously, when it comes to composite materials, nylon carbon fibers usually get all of the attention, and those are the materials that are most talked about. But there are also advantages to using ABS, and I'll let you talk to some of them. But I think one of them that I see is the lower moisture absorption, which you have with the nylon, which has 2 advantages. It's doing the printing. Obviously, if your filament absorbs moisture, you can see stringiness and other defects. So you have to really control the moisture. And then obviously the printed part itself can also absorb moisture and change properties later. So I think that's one of the advantages that I see of using ABS. Yeah, definitely.
And the next one I wanted to talk about was, I have to move this down, is ABS-ESD. So like I said before, we see more and more traction towards this material by industrials today. So ESD stands for electrostatic discharge. So, it's especially used in environments where you need to dissipate an electrical charge. So you don't need a conductor or an insulator, but something that is able to dissipate slowly, so to avoid to have a electric shock. Yeah. So its main role is to be able to create a slow enough discharge to avoid damages to materials. So it's used a lot in by factories or in companies that have electronics around, electrical equipment. And in most factories, you have electric equipment. And so this is a material that is very interesting because you can print a lot of parts in a part of your assembly line to avoid electrostatic discharge. So this is our material, and the case study we have. Unfortunately, I can't show you a picture because it's a confidential case study, but it's a case study where using this part, the company was making a sealant part where they needed anti-electrostatic properties to provide a thermal protection between 2 parts. So it's actually 2 parts printed separately, 2 separate parts that come together when they're assembled. So they needed to produce 300 parts for a production line, and the parts would also have to be removed and reassembled multiple times during the life cycle of the machine. So they chose ABS-ESD. And what is interesting is, they did a bit of comparing between ABS-ESD and a traditional part. And once again, we noticed that the material waste was reduced by 80% based on their regular part. And also the parts cost 70% less. So, this is like, when we see applications like this, we really understand why sometimes, a lot of times it's easier to turn to 3D printing instead of the regular production of parts.
Yeah, no, that's great. There are also two questions that I see here in the Q&A. One was why ABS with carbon fiber and why not ASA with carbon fiber?
Well, ASA, the advantage of ASA, it really depends on the conditions. ASA is something we advise when it's, outside conditions, when, for different applications. So it's got the environmental resistance that ABS doesn't have. So it depends on your application. We have an ASA, but we don't have a composite ASA. So, if the person is looking for something lightweight and with more rigidity, and it's an indoor application, I think ABS carbon would do the job. But ASA compared to ABS has other advantages. Like I said, it's for.
That makes perfect sense. And then the second question was, is ABS carbon electrically conductive?
No, it's not electrically conductive. No, we have another filament that is actually, we call ABS-EC. That's an electrical EC for electricity conductive, but no, ABS carbon is not.
Yeah, okay. Yeah, no, that's a great material to look into as well. Great. This is very interesting. I think let's move on to Nate maybe and talk about the UltraFuse 316L.
Yes, so I suppose if you can bring up that presentation, but in the meantime, right, so from our portfolio, I'll focus on our metal material. So let's just say both 316L and the 17.4pH, which was more recently released. So right, in the general discussion of when to use selecting what kind of material, right? Right. So from our perspective, right, you kind of have to start by going backwards and really identify what are like the key criteria that are needed for your end use or for that end part. So although my sales colleagues would probably not like it, if you don't need a metal part, you should probably not use it, just because it is a more complex process and it can be overkill. So if you just need a prototype, you probably don't, some visual prototype, then yes, a PLA or an ABS will suffice. But there are certainly many applications where metal is needed. So in our recent experience, we do see a lot of people interested in metal, and they come from different areas. So we have traditional MakerBot users that have used like the polymer materials and are interested in metal materials, but there is an entire secondary process that they have to go through. But on the opposite hand, there are a lot of people primarily experienced with using metals, but they have to really learn how to really design for a metal 3D printing process. So, right, so continuing from that, as you can see a couple of sample parts here, where we see a lot of benefit to end users of much faster turnaround times, as opposed to having to send out a part to a machine shop to get produced. You can do it essentially whenever you want by yourself. So we enable a lot of end customers to have much faster innovation cycles, to reduce costs, to have much more advanced and sophisticated geometries that are either impossible to create via traditional metal working processes or just very expensive. So, Johan, if you could,
this is just one thing I wanted to mention here. What you just mentioned is that, if you don't have to print it in metal, don't do it. This is why, like in these two examples, we highlighted basically the combination of nylon carbon fiber together with metal parts. So here, only the parts that really needed that extra strength of the metal, because there is a very significant step up, right, from nylon carbon fiber, from any of the other materials when it comes to strength, obviously printing it in metal and getting it sintered. it's much, much stronger. So the idea here is that only print the elements that you absolutely, where you need that strength. And that really enables you to print parts that previously you would have to machine. Like if you have to have a certain strength that you can't, where your nylon carbon fiber is not sufficient, that's exactly where it comes in. And I think it's a huge benefit, but I'll let you talk a little bit more about the process.
Right. Yeah, thanks, Alon. So just in general, it's like setting the kind of the playing field, right? So like a stiff polymer material, let's just say it's around 100 megapascal of tensile strength, but with some of our 17.4 base materials, you should be able to hit 850 to 900 megapascal of tensile strength. So you're talking almost one full order of magnitude higher in strength and stiffness. So, but yeah, just as like a general overview, it is very important to continue educating people about bound metal powder 3D printing. So in general, you'll start with you'll print your end part, such as this gear that you can see up on the very top. It certainly benefits from the MakerBot printer with the heated chamber, just because of that binder that binds all those metal powders together. Does have a tendency to warp, especially if there's a great temperature differential or temperature gradients. So yeah, it's a key benefit of that MakerBot platform. But once you get that finished metal part, we oftentimes get questions of like, well, can you use the green part like after you finish printing? It's like, well, you could, but it's essentially just very, very small particles that are essentially glued together. So you have a little over 10% of like an organic binder, which is certainly not conductive. You also have these metal powders that are, it's essentially like the metal powders haven't fused together, that creates that density and that high strength. So I'll bring up another slide later, but once you get that part printed, you'll send it externally to do the debinding and sintering process. So yes, we have this picture here. We've partnered with a company, DSH Technologies. They are based out of New Jersey, experts in debinding and sintering. So they're also very involved in the metal injection molding industry. So that's why very experts in this process. So right, we also get some of our expertise from our Catamold, which is a traditional metal injection molding industry as well. So we do get a lot of synergies there. But yes, once you send the parts to DSH, it gets debinded and sintered. So these are two separate processes. During that debinding step, we're using an acid catalyst to really eat away and remove 90% of that organic binder. So after you get debinded, it has that consistency of like a wet sandcastle. So by no means is it strong, but it's in a fragile state where you have to take that part which has lost most of that binder and to send it to this sintering oven, which you can see here. And right during the sintering process, rather complex process, but for stainless steels, we oftentimes have to hit between 1300 and 1400 degrees C to get that finished sintered part. And then, yeah, let me see. Yeah, I think Johan, if you have to stop. Okay, no, this is a good point. This is a good point. Sorry. So yeah, another. So I'll show like an example here. So this is actually from a previous project with L3 Harris. I think we have another participant on the line from L3 Harris, but yeah, for example here, L3 Harris, they had a desire to bring in more metal production and additive technologies in-house, just because it really aids in that product development and innovation cycle. So with this process, we identified several parts. So these are tooling aids and fixtures as part of an assembly. So on the bottom here, you can see the part going from the green state, which is as printed, to the brown state, which has the majority of that binder removed, and then to your final sintering state. So there is about 20% shrinkage in that XY plane, and then 26% in that Z plane. So there is slightly different shrinkage rates for XY versus Z. But during this process, you can see, working with L3, we have that center part on the top left. but for the end part, there are some additional machining steps. So for metal parts, we are quite confident you can get near net shape final part with high degrees of accuracy and dimensional tolerance. But sometimes you have to be aware that some post-processing may be needed. So for here, it's just machining it and sanding and polishing it as well. But yeah, I just wanted to make that aware, and so everyone can understand that for that process. So, but yes, for this is kind of a general overview of that metal debinding and sintering process. And I think, Johan, if you could stop sharing, I could also bring up one of my screens here.
Yes, and there are also two questions that I saw here. One is, are there particular specifications for shipping green parts off to be sintered? How do you protect the parts from being damaged in shipping, assuming they're susceptible to damage?
Right. So yeah, to answer that question, the part as it's printed is actually quite strong. I wouldn't recommend trying to do an impact test on this green part. So you can definitely just pack it with a sufficient amount of bubble tape and foam. There is a standard process on some of our distributors' websites about how to actually do this. So I can, of course, redirect you to learn a lot more information there. But right, it's essentially a bubble wrapped envelope mailer is not sufficient. So you'll definitely have to have enough packaging. So just so it withstands that transfer process.
Okay, great. I'm also getting a reminder here that we're starting to run out of time. But I think, yeah, I think the metal printing, obviously it is more of an involved process, but for what you can get out of it, it's absolutely worth it. And it's amazing that you can get those kind of parts out of a $5,000 printer. I think it's really a big step forward. And I think you guys are taking the right approach. You put in place a good process for it, right? And you're going to continue to innovate on that and streamline that process more for customers.
One last point, because I don't want to take time. So yes, there are certainly people who are asking, like, oh, what's the next metal material? So we are very actively looking into other metal materials to bring to the market. So there are other common materials that we're evaluating. We don't have anything yet to announce, but yes, rest assured, more is on the way. And right, we're still working on optimizing this debinding and sintering process as well. So yes, we are very aware of what the customers want and are actively working on getting it there. So yeah, thank you.
Yeah, no, that's great. And I also do want to get to kind of the question of the future and where we think the trends are and what's next, without revealing too much. But before we go there, I want to also give Nico a chance to talk about one of the polymaker materials and applications as well.
Sure, thank you. I promise I'll make it quick. So for our polycarbonate, so we are offering our Polymax PC, PCFR flame retardant, and our Polylite PC and PC PBT on the labs program. But I would like to focus, so a very quick introduction. Polymax PC was one of our first polycarbonates with Polylite PC. So these two were really designed for a desktop 3D printer that were not coming with the heated chamber. And then thanks to these new platforms, such as the Method X, then we were able to develop more material, such as the PCFR and PCPBT. So I won't be too long on the introduction of the material. So let me dive into one story about one of our customers that were using Polymax PC at the beginning. And then thanks to the evolution of printers, we're finally using PCFR. So it's from a company, Laboratory Technologies, LTI. So Jeffrey, a very nice guy. And then, so basically what you see on the left is the machine they had before with traditional manufacturing method. So why they have this cubic more design compared to the right one, it was more to be more cost effective, because they were dealing with machining CRS, so the machining steels. And when it comes to make curve or to make like bombed covers, it can be very, very expensive. And actually the pipe that you see on the left is quite hard to make with the traditional tooling. So they didn't know anything about 3D printing. What they did is they bought a regular desktop printer, a very cost-effective printer, and then they learned about printing. A couple of months they were printing, and then they were learning what was possible. And then finally, they ended up, modifying the design and learning what is possible with 3D printing. So that's why they came up with the design on the right. And this flexibility in design allowed them to make something that is much more appealing as a product and safer. You don't have this, cubic design, and the internal can be better design. And this, the picture itself was using Polymax PCFR, but at that time they didn't have access to the right tools in order to process engineering materials. So they were using Polymax PC at that time that were more designed for the process. Actually, we always ask, how can I choose which material to use? And rather than jumping directly into what mechanical properties do you need, what do you need, any chemical resistance, etc., I think the first question is, what tools do you have first? Are you looking to invest into, an industrial printer? Are you looking to invest into more consumer-oriented printers, or do you already have a printer? And that will already narrow down the materials that you will be able to use. The second question, still before going into mechanical, is the budget. Are you looking at a material that is cost-effective because it will be a big part of the cost of your product, or the opposite? It will be a small part of your product, so the cost is not really the question there. And after that, then you can go in the regular, are you looking for a higher modulus, impact resistance, etc. And then that will really help you to define the right products. So they did that process, and they defined Polymax PC at that time as the right product. And then came out a better printer that could print a wider range of materials. And then that's how we, as a material manufacturers, understand a little bit more what tools our customers now have access to. So we can design a material that is much closer to their need. And in this case, they're designing products for radiation measurements. So they need the material to be flame retardant and have some certification. So that's how we partner with Covestro in order to design this Polymax PCFR. And then they really learn about how to use 3D printing, not for prototyping, but to make an actual product, an end product. So obviously, first you need excellent dimensional stability. So as you can see on the slide, the heated chamber for polycarbonate is a key factors to control the material behavior. You will have, even if you are able to print polycarbonate without a heated chamber, you will still have a dimensional issue. And when you have intricate parts, you do need an excellent dimensional stability during the printing. And the second one is post-processing. So I think Johan will ask a little bit more about future trend, etc. And I think post-processing is part of it. So they learn how to post-process the part in a cost-effective way in order to make the part a product. And finally, so that's a word from Jeffrey. So our new 3D printing design is as strong as the CRS. So the most important now is they are trying to replace a product that they already had. So they cannot compromise on the actual functionality of the product that they had. However, this product was as strong, and it weighs 10 pounds less, and dropped the price and became 25% of the original parts. And obviously they learned a lot. And one thing that they learned is now they can prototype, they can design, they can iterate with 3D printing, and they can also use 3D printing to go into production directly. And the last part is more on the investment. So although they didn't know anything about 3D printing, the whole learning process, the whole investment took only a bit more than 1 year. And now they are already enjoying the switch that they have done to 3D printing. So I think that's a really beautiful story about how 3D printing can help business innovating and grow.
Yeah, that's pretty amazing. That's a great case study, I think, to also have the actual business case and showcase, how quickly they were able to recover the cost and then basically turn it into like a positive investment that they made. That's great. I know we don't have a ton of time left, so 3 minutes left. So let's quickly, this actually, I wish we would have had more time, but maybe we could probably have a whole session just about this topic in terms of where are the trends and where do we, I come from the product side, obviously, so I would phrase it in this way, like, what are the biggest gaps for the customer that we think need to be solved over the next couple of years, that need to be worked out? And maybe Misha, maybe we start with you to talk about that.
Yeah, I'll try to go quickly on this.
Yeah.
So yeah, what are the opportunities, or what are unmet customer needs? I think like what Nicolas said just now, post-treatment, so post-processing is something that a lot of customers are looking for, and we have to still improve the process on our side, materials that do not necessarily need post-processing. And for example, we have a researcher internally who's working on a topic on how a reaction during the printing, the extruding itself of a flexible, allows the material to be stronger. So those are sort of innovations that we are currently working on, and would be able to answer hopefully some of the customer needs today. And just to go quickly on another trend, which I think we are all seeing now, and we see more and more, is we have a lot of industrials coming to us asking how they can reuse their waste. And we have a lot of examples of, for example, a cosmetics company, a big cosmetics company in France, for whom we produce filament out of their own waste, the empty shampoo bottles waste, for example, to reuse industrial waste to produce filament, which is then used in their company. So they buy back to use it internally for prototyping or to replace parts in their factories. So that's a trend we're seeing. More and more companies coming to us asking how we can use their waste, their polymer waste, into filaments. So it also reduces, answers the gap we have today on supply issues regarding plastics. So I think that's one of the trends we're seeing globally in our industry today. Thank you.
Great, thank you. We don't have a lot of time, but maybe Nate, you can go next, and then Nico,
Yes.
quickly.
Yeah, very briefly. So some things that BASF as a team and as an organization is looking at is other factors, including aesthetics and other services. So we do have various coating materials that you can actually apply to a printed part if you need a special color, which we've seen more and more customers are interested in. So that process may be easier and more accurate to achieve a specific color that you're looking for, rather than developing an entire new material. But also, right, like I mentioned before, we're still really trying to use other simulation services and other printing services to really enable faster adoption of, I guess, engineering grade and advanced applications too. So yeah, BASF as a team has some foundational experience in material developments and like polyamides, TPUs, high-tech materials as well, but also like simulation services as well. So yeah, that's where we're trying to push as well.
Okay, great. Nico, your turn.
Yes, very quickly. So post-processing, definitely a big trend. We need to be able to post-process parts in order to enter new industry, which could be end product using 3D printing for end use. Second one, a little bit strange, but color. There have been a lot of development around how can you print something colorful in extrusion-based 3D printing. That's a question that is trying to being answered, but a lot of some company thinks that is going to be within the process itself. You're using different filament, you mix filaments. Some company thinks that it's in the post-processing. So, and the question is, where are we going to be? The third one is speed. Extrusion-based 3D printing still have deficient in speed. We do need ways to being able to print with larger nozzle, but directly switch to smaller nozzle for details, or we need hardwares that are capable to print faster. So that would be the third one. The fourth one is sustainability. Definitely that's the trend at the moment, and not only in our industry. And so our industry has to follow this sustainability. Polymaker has released more products that are more sustainable oriented, and actually the Method X this platform allow us to release, for example, a recycled PC, because this recycled PC couldn't be done before because it requires a very certain printing condition. So I'm happy that, you know, printer manufacturers can collaborate to go towards the trend of sustainability. And the latest one is reliable process for the sustainability. You know, if I give you a very quick example, 3D printing at the moment is like using your 2D printer. You print an A4 paper, and 1 out of 2, you throw away the paper because of fail or because of, I don't know, support removal. For 2D printing, that's not viable. You know, you don't want to throw away an A4 paper every 2 print. But at the moment, we partner with, you know, some software company that are monitoring, you know, failure rate from printers, and sometimes it go up to 50%. That's huge, and that's you know, that's a big waste of plastic. So that goes into sustainability. And I will just add one more point for post processing. You know, PC needs annealing. And what I really like about the method is that they had a very specific process that at the end of the print, you can have an automatic process that will anneal your part thanks to the feature within the method. So again, I started by this, but I will finish by this. The collaboration between material and printer manufacturers is really key to 3D printing industry development.
Thank you. Yeah, no, I agree. And I think this is such an interesting topic. We should have a follow-up session on this. Just what are the future trends, and go into more detail. So I think that would be a very interesting next one that we could have. So thank you, all of you, for participating. This was too short, I would say, but very interesting. And yeah, I look forward to another session.
Thank you.
Thank you. Thank you for having us.
Yes.
Thank you. Bye.
Bye.
Thank you, everyone. Be sure to join us on our next session, Women of Additive Manufacturing.